Hello, my name is Daniel, and today we will be going through the AMC 12B from the year 2010. So let's get started. First problem, Makarla attended 2 meetings during her 9-hour workday. The first meeting took 45 minutes, and the second meeting took twice as long. What percent of her workday was spent attending meetings? Okay, so her total time at work is 9 hours. Her meeting was 45 minutes, but then her second meeting took twice, so the whole thing is times 3, but then this is in minutes, right? So to make that in hours, 45 minutes is 3 over 4 hours. That's gonna give us 9 over 4 over 9, so these two are gonna cancel. It's 1 over 4 of a workday. That is 25%, so that's the answer. It's C. Number 2, a big L is formed as shown. What is its area? And so we can just do this. We know that this is 8 times 2, this is 16, and since this much is 5 minus 2, which is 3, that means this much is 6, right? And so if we add these together, then we get 22, so the answer is A. Number 3, a ticket to a school play costs X dollars, where X is a whole number. A group of 9th graders buys tickets costing a total of $48, and a group of 10th graders buys tickets costing a total of $64. How many values for X are possible? We know that 48 and 64, they are both multiples of this X. And the greatest common denominator of 48 and 64, this is 16, which is 2 to the 4th power, and X is a factor of this, right? And so the number of factors of 2 to the 4th power, this is 5, and so we have 5 values for X. It's E. Number 4, a month with 31 days has the same number of Mondays and Wednesdays. How many of the 7 days of the week could be the first day of this month? Okay, so since the month is 31 days, and 31 equals 7 times 4 plus 3, that means we have 3 extra days in addition to the normal 4 weeks. This means that if Monday and Wednesday has 5 days, if it has 5 days, that means that the month should start on Monday, because those extra 3 days that will go on Monday, Tuesday, and Wednesday, right? And then if Monday and Wednesday has 4 days, so 4 Mondays and 4 Wednesdays, right? That means Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, or Sunday. 3 of these will have to contain the extra 3 days, right? So that's gonna be these 3 or these 3, so that's 2 ways, right? 2 ways. And so we have 1 way plus 2 ways, that equals 3 ways in total. 3 ways. So that's the answer. It's B. Number 5, Lucky Larry's teacher asked him to substitute numbers for A, B, C, D, and E in the expression A minus B minus C minus D minus minus D plus E with all those parentheses and evaluate the result. Larry ignored the parentheses but added and subtracted correctly and obtained the correct result by coincidence. The numbers Larry substituted for A, B, C, and D were 1, 2, 3, and 4 respectively. What number did Larry substitute for E? Okay, so if we do this correctly and we get rid of all the parentheses, that should be A minus B plus C minus D minus E. But then if he just did it like this, ignoring the parentheses, then that would just be A minus B minus C minus D plus E. So if we just put in 1, 2, 3, and 4 in here, no, actually, we know that these two values are equal. So these two are equal, and we can cancel A minus B and minus D. So this gives that C minus E equals E minus C. That means E equals C. So since C was 3, that means E is also 3. So that's our answer. It's D. Number 6, at the beginning of the school year, 50% of all the students in Mr. Wells's math class answered yes to the question, do you love math? And 50% answered no. At the end of the school year, 70% answered yes and 30% answered no. Altogether, X% of the students gave a different answer at the beginning and end of the school year. What is the difference between the maximum and the minimum possible values of X? Okay, so our maximum value is when all of the no students answered yes. That means 50% changed from no to yes. And this 30% that answered no, those were students that answered yes. That means 30% changed from yes to no, right? Yes to no. This gives us a total of 80% change. And the minimum, this is when this 30% was the same people who answered no at the beginning. So that means just 20% of no went to yes. That's why 50% became 70%, and just the people who answered yes stayed. So that means 20% changed from no to yes, 20% change. And so the difference between the maximum and minimum possible values of X, this is the difference, which is 60%. So this is the answer. It's D. Number 7, Shelby drives her scooter at a speed of 30 miles per hour if it's not raining and 20 miles per hour if it is raining. Today she drove in the sun in the morning and in the rain in the evening for a total of 60 miles in 40 minutes. How many minutes does she drive in the rain? Okay, so since 30 miles per hour, if we just convert it to minutes, then this becomes half a mile per minute. And same thing, 20 miles per hour, this becomes 1/3 mile per minute. So if we say that the times will be n and r for not raining and raining. So if we use that distance equals time times speed, then we would get 1/2 n plus 1/3 r equals 16. And since they are times and they sum to 40 minutes, that means n plus r equals 40. And so if we multiply that by 6, that will give us 3n plus 2r equals 96. And so using that, we know that 2n plus 2r equals 80. If we subtract, that gives us n equals 16. So r must equal 24. So the time in the rain was 24 minutes. It's C. Number 8. Every high school in the city of Euclid sent a team of 3 students to a math contest. Each participant in the contest received a different score. Andrea's score was the median among all students, and hers was the high score on her team. Andrea's teammates, Beth and Carla, placed 37th and 64th respectively. How many schools are in the city? Okay, so since each school sent 3 students, right, and this is so those are the number of schools. And so to get the number of participants, we have to multiply it by 3. And so this would be 66 participants, this would be 69, this would be 72, this would be, that would be 75, and this would be 78. But then since Andrea's score was the median among all students, right, so there was a median scorer, but then each participant received a different score. So for the median to actually be an actual score, that means that the total number of participants must be odd number. Right, so this and this are possible, but these 3 are even, right? And so that means that these 3 cannot be the answer because they have an even number of participants, and Andrea did have the median score. So if it's 69 or 75, then we know Andrea's placing. Then if it's 69, then that means Andrea was 35th. And if it was 75, this means Andrea was 38th. But then we know that Andrea's was the high score on her team, but then Beth placed 37th, right? So that means Andrea must be scoring higher than 37th place. That means A is the only option, so the answer is B. Number 9, let n be the smallest positive integer such that n is divisible by 20, n squared is a perfect cube, and n cubed is a perfect square. What is the number of digits of n? First, we know that since n is divisible by 20, let's set n equal to 20 times a. And since we want n to be the least possible, let's say a is equal to 2 to the x power and 5 to the y power. That will give n equals 2 to the 2 plus x power times 5 to the 1 plus y power. So that means if we square, and so n squared, that will give us 4 plus 2x power of 2 and 2 plus 2y power of 5. And so these are both going to be multiples of 3. And if we cube these, then that's going to be 6 plus 3x, 3 plus 3y, right? So that's going to become a multiple of 2. First, from this thing, since they both have to be even, that means this is even and this is odd, right? So this means that x is even and y is odd, right? And from this thing, since those have to be multiples of 3, that means 2 plus x and 1 plus y, they are both multiples of 3. So 2 plus x and 1 plus y, multiples of 3. And so the least values where x is even and y is odd, and they will be a multiple of 3. X is equal to 4. And y is equal to 5, right? So that will give us n is going to be equal to 2 to the 2 plus x, which is 6, and 5 is going to be equal to 1 plus 5, which is, so this is going to be 10 to the 6th power, and so this is going to be a 7-digit, right? So this is going to have 7 digits. So this is the answer, it's E. Number 10, the average of the numbers is 1 to 3 all the way to 99, and x is 100x. What is x? Okay, so we have these numbers and their average. That will be, there's 100 numbers in total, right? So it's all over 100, and then it will be 99 times 100 over 2. That's the sum from 1 to 99, and x, right? So we have to do plus x. This equals 100x. And so we know that 99 times 50 plus x equals 10,000x. And so if we just move the x, then this will just be equal to 9999x. And so dividing by 99, we get 50 equals 101x, so that means x is equal to 50 over 101, right? So this is the answer, it's B. Number 11, a palindrome between 1,000 and 10,000 is chosen at random. What is the probability that it is divisible by 7? Okay, so since this is a palindrome, that means it's in A, B, B, A form. But then now we know that 1001, this is a multiple of 7. But B, this one, that gives us 110, but then 110 is not, right? Yeah, so that means that in A, B, B, A, that means A can be anything from 1 to 9, but B can be only 0 or 7. Right? But then all the palindromes between 1,000 and 10,000, that's going to be all the palindromes. Those are going to be A, B, B, A, with A is going to be all from 1 to 9, and B is going to be everything from 0 to 9, right? So this is going to have 9, and this is going to have 10, but this is going to have 9, and this is going to have 2. And so we have this over this, so that's 9 times 2 over 9 times 10. This is equal to 1 over 5. So this is our answer, it's E. Number 12, for what value of x does this equal 40? Okay, so first we need to notice that every one of those values are equal to log 2 of x, because this is just 1/2 over 1/2 of log 2 of x, so that's just going to be the same thing. Same for here, this is going to be 2 over 2 and 3 over 3 and 4 over 4 of log 2 of x. That means they're all just the same thing, so it's going to be 5 log 2 of x. So if this is going to be 40, that means log 2 of x is equal to 8. So x is going to be equal to 2 to the 8th power, which is 256. So this is the answer, it's D. Problem number 13. In triangle ABC, cosine 2a minus b plus sine a plus b equals 2 and ab equals 4. What is BC? First, we notice that this and this, they sum to 2. But then we know that cosine and sine, their maximum values are 1. And so for that to happen, this has to be at its maximum, and this also has to be at its maximum. So we know that cosine of 2a, 2 large A minus b, this is 1. And sine of a plus b, this is also 1. And for cosine 2a minus b to be 1, that means 2a minus b equals 0 or pi. And sine a plus b equals 1, for that to happen, a plus b, this must be equal to pi over 2, because it's either this or 3 over 2 pi, but then it's a triangle, so that must not happen. And since a plus b is pi over 2, then that means that c, that's going to be equal to pi minus pi over 2, which is just pi over 2, right? And so if we put out a diagram here, then this is going to be A, B, and C. And since C is 2 over pi, so that's going to be like a 90-degree angle. So now we just need to find out those two. And since c equals pi over 2, that means 2a minus b, this cannot be pi, right? So it must be 0. That means 2a equals b. But then a plus b equals 90 degrees. So that means a equals 30 degrees, and b should equal 60 degrees, right? So this gives us that this is 60 degrees and this is 30 degrees. So this is a 30, 60, 90 triangle. But then we know that ab equals 4. So this is 4. And since this is 2 to 1 to root 3, that means this is 2. Right? So we know BC, that is 2, and that is the answer. It's C. Number 14, let A, B, C, D, and E be positive integers with A plus B plus C plus C plus E equaling 2010, and let M be the largest of the sums A plus B, B plus C, C plus D, and D plus E. What is the smallest possible value of M? So to make M as small as possible, then we should make all of these equal, so that the smallest of those is equal to the largest of those. And that would just be when A, B, C, D, E are just A, B, A, B, A. And all the sums would be just A plus B. So this is just A plus B. A plus B, and so because of that, we can get that 3a plus 2b equals 2010. For a plus b to be its minimum value, a plus b minimum, we know that a plus b equals 2010 minus a over 2, and so for a plus b to be its minimum, that means a must be its maximum, right? A must be its maximum, and so we need to find the maximum value of A, where A and B are both integers, and so that would be when B is equal to 3. And so if B is equal to 3, then A would be equal to 668, and so what we wanted was A plus B, so those two together, that gives us 671, right? And so so that's the answer, it's B. Number 15, for how many ordered triples x, y, z of non-negative integers less than 20 are there exactly two distinct elements in the set these three, where I is equal to root of -1? Okay, so since we have 3 elements, but then we want 2 distinct elements, that means 2 of these are the same, right? 2 are the same, 1 different. So first let's look at ix and z. If I to the x power is equal to z, and for this to be a positive integer, that means z has to be equal to 1. X can be equal to any multiple of 4. That can be 0, 4, 8, 12, or 16. And since this whole thing has to be 1, that means y cannot be 1. Right, so this cannot be 1. No, yeah, so this cannot be 1, therefore y cannot be 0. Right, so y cannot be 0. And if it's this, and if it's these two that are the same, if I to the x power equals 1 plus I to the y power, that means they must equal, they both should be 1. So that would give us x can be same as before, 0, 4, 8, 12, 16, so y must be equal to 0 because that's the only way that y becomes 1. Since these two are 1, that means z cannot be 1, so z is not 1. And lastly, if these two are the same, if 1 plus I to the yth power is equal to z, so we have two possibilities for this. First of all, they can just be both 1, with y being 0, and z can be 1 because z must be 1, and x cannot be 1, and I to the x power cannot be 1. That means x cannot be any of these. X cannot be 0, 4, 8, 12, or 16. But if you notice that 1 plus I squared equals 2I, then 1 plus I to the 4th power equals minus 4. That means 1 plus I to the 8th power equals 16. So we can make that possible, and so that will be, both can be 16, with y is going to be equal to this much, which is 8, and z is equal to 16. I to the x power can never be 16, so x can be anything. X can be anything. And so now, if we see, we have this, so it's either that, or this, or this, or this, right? And so this gives us 1 times 1 for z, and 5 for x, and then y cannot be 0, so it's all except for 1, so 19. And this gives us 5, 1, and 1. No, 5, 1, and this is 19. So that's 5 times 1 times 19. And this gives us 1 times 1 times everything but 5. So that's 1 times 1 times 15. 1 times 1 times 15. This gives us 8 and 16. So that's all 1 and 1. And x can be anything. So that gives us 1 times 1 times 20. And so we know that this is equal to 95. This is also equal to 95. It's the same thing. And this is just 15. And this is 20. And so these will all sum to 225. And that is the answer. It's D. Number 16. Positive integers a, b, and c are randomly and independently selected with replacement from the set 1 all the way to 2010. What is the probability that abc plus ab plus a is divisible by 3? Okay, so since we know that ABC plus AB plus A, this is A times BC plus B plus 1. It's divisible by 3. First of all, if A is divisible by 3. So if A is divisible by 3, that would be just 1 over 3 probability. And then we will need that to be divisible by 3 only if A is not divisible by 3. So A is not divisible by 3. BC plus B plus 1. This is divisible by 3. And then that will be, this is 2 over 3. And we need to get this. So if we look at this, this is going to have 3 possibilities. First is if, 3 cases. The first case is if B equals 3k. B is in B equals 3k form. But then if that happens, then these two are multiple of 3. That means the whole thing will be a multiple of 3 plus 1. So that means this is never gonna, so that means it's never gonna be divisible by 3, so that's out. If B is 3k plus 1, then the only way for it to be divisible by 3 is when C is in 3k plus 2 form. And lastly, last case, if B is in 3k plus 2 form, then the only way is for C to be 3k plus 1 form. That's the only way for the whole thing to be divisible by 3. This is just going to be nothing, and this is going to be 1/3 plus 1/3. That's going to be 1 over 9. This is also going to be 1/3 plus 1/3, which is also 1 over 9. And so this plus, and then we're going to have this, which is just these two added together, right? So that's just 2 over 9. And this whole thing is equal to all over, that has to be multiplied by, right? That has to be multiplied by 2 over 9, right? So this is equal to 4 over 27. And now we have to add this one and this one. Those are going to be 1 over 3 plus 4 over 27, which is equal to 13 over 27. So this is the answer. It's E. Number 17. The entries in a 3x3 array include all of the digits from 1 through 9, arranged so that the entries in every row and column are in increasing order. How many such arrays are there? This is what's called, so if we draw this like that, then this is what's called a standard Young tableau. You have seen in my other video the number of standard Young tableaus. This is equal to n factorial over the product of its hook numbers. This n is the number of things in here, like that, right? And so this is going to be 9 factorial all over, and then if we write out the whole numbers, it's going to be 1. We have this, so that's 2. This much, that's 2. This much, so for this one we have these 3, so it's 3. This one, it's 4, and it's 3, and same way 5, 4, 3 all over. No, let's just write out 9 factorial. That's going to be 9, 8, 7, 6, 5, 4, 3, 2, 1 all over 5, 4, 3, 4, 3, 2, 3, 2, 1, right? 5, 4, 3, 4, 3, 2, 3, 2, 1. And so we can cancel these two, and 4, and 5, and 6 is 3 times 2, 8 and 4 will be 2, 7 and 9 will be 3, so this is going to be equal to 3 times 2 times 7 equals 42. So the answer is 42, which is D. Number 18. A frog makes 3 jumps, each exactly 1 meter long. The directions of the jumps are chosen independently at random. What is the probability that the frog's final position is no more than 1 meter from its starting position? Okay, so if we just make a diagram here, this will be the shape, but then what this represents is the possibilities of the final position, the second position, and the initial position, right? So if we say that the frog was right here at its first jump, it could have gone anywhere from on the circumference of that circle, but then since this is just the first jump, the location doesn't really matter, so let's say it just went here. So this is the second jump site, and from here it can jump from jump to anywhere on here. And so let's just say that it went anywhere like that, and then from here it can jump anywhere on that circle. So for all of the possible center values that this can get, then we are going to have an infinite number of circles like that, right? That is going to be, and those are going to be possible numbers of, and so the frog's final position can be anywhere inside of this area. So the frog's final position can be anywhere of here, but then it has to be no more than 1 meter, from its starting position. And this area is being 1 meter from its starting position. So that means we have this much here out of this whole thing. And so let's say that this radius is 1, right? Because it's 1 meter long, and so then this will be 2 meters. And so this full circle, right, so the whole thing is pi r squared, which is pi times 4. That under, and then the numerator will be this much. So that's just pi times 1 squared, right? So this is going to be equal to 1 over 4. So that's the answer, 1 over 4. It's C. Number 19. A high school basketball game between the Raiders and Wildcats were tied at the end of the first quarter. The number of points scored by the Raiders in each of the 4 quarters formed an increasing geometric sequence, and the number of points scored by the Wildcats in each of the 4 quarters formed an increasing arithmetic sequence. At the end of the 4th quarter, the Raiders had won by 1 point. Neither team scored more than 100 points. What was the total number of points scored by the 2 teams in the first half? So let's just say that the number of points scored by the Raiders and the Wildcats in the first quarter, that was A. So Raiders, Wildcats, that will give us A. And since Raiders, it increasing geometric sequence, so that will be A, AR squared, and AR cubed. And Wildcats, that's an arithmetic sequence, so that will be A plus D, A plus 2D, and A plus 3D. So if we take the sum of those, then the sum is going to be A times 1 plus R squared plus R cubed, which is just equal to A times 1 plus R and 1 plus R squared. 1 plus R squared, right? And for this one, the sum is 4A plus 6D. For this one, it's at the end of the 4th quarter, the Raiders had won by 1 point, so this is 1 more than that. So this gives us that A 1 plus R, 1 plus R squared, 1 plus R squared. This is equal to 4A plus 6D plus 1, right? So we know that this is an odd number because it's even plus 1, so it's odd. And so we know that this must be odd, right? this must be odd. So A must be odd, and R must be even, right? So that way this and this they're odd. So R must be even, and so let's start with the least value of R. R is 2. Then that will give us that this is 15A, right? So 15A equals 4A plus 60 plus 1. So 11A equals 60 plus 1. And so this will give us A equals 5 and D equals 9. We start with the lowest number since it said that neither team scored more than 100 points, right? So now let's try for R equals 4, which is the next highest. Then this will give us 85A equals 4A plus 60 plus 1. So 81A equals 60 plus 1. The only way for greater than 100 is for A to be 1, right? So A should be 1. But then that means 60 is 80. So D won't be an integer, right? And so that means this is just all gone, right? And so R is equal to 2. That would be our answer. What we want is the total number of points scored by the two teams, right? And we know the values of R, of A, and of D. And so the total number of points scored by the two teams in the first half, this is this much. This is 3A plus D plus AR. This is equal to 3A, so that's 15, plus D, that's 9, plus AR, that's 10, right? This is equal to 34, so that's the answer, it's E. Number 20. A geometric sequence AN has A1 equals sin x, A2 equals cosine x, and A3 equals tangent x for some real number x. For what value of n does AN equal 1 plus cosine x? Because of these two, we know that the common ratio, I'll call that R. This is going to be equal to cosine x over sine x, but then we don't know that this is cotangent x. And so applying this to A3, then we know that A4 equals tangent x times cotangent x, which is 1. So A4 is 1, and the common ratio is R. That means A3, this can just be seen as 1 over R, A2 is 1 over R squared, and A1 is 1 over R cubed, right? So if we just write that, A1 equals 1 over R cubed, A2 equals 1 over R squared, and A3 equals 1 over R, and so on. And then now we can use the fact that these two squared sum to 1, right? Because cosine squared x plus sine squared x always is equal to 1. So 1 over r to the 4th power plus 1 over r to the 6th power equals 1. Because that's just putting these two inside. And so multiplying everything by r to the 4th power, this gives us that 1 plus 1 over r squared equals r to the 4th power. But then we know that 1 over r squared equals cosine x. So 1 plus cosine x equals r to the 4th power. But then if we continue with this, right, that's going to give us a 4 equals 1, a 5 equals r, a 6 equals r squared, a 7 equals r cubed, and so a 8 equals r to the 4th power, right? So this is a8. So this is a8. And so now we know that 1 plus cosine x equals a8. And that's what we've been looking for, right? So because of this, we know that this is the value of n. So 8 is n. The answer is E. Problem number 21. Let a be greater than 0 and px be polynomial with integer coefficients such that this is all equal to a and this is all equal to negative a. What is the smallest possible value of a? Looking at this, we can say that px minus a, this is going to have roots of 1, 3, 5, and 7, right? So those are going to have roots of 1, 3, 5, 7. So that's going to be x minus 1, x minus 3, x minus 3, x minus 3, x minus 5, x minus 7 times, and then something else. Let's say it's q of x, right? Let's say it's qx. And we can just plug in 2, 4, 6, 8 values, because that means that will become minus a. And so if we plug in p of 2, if we plug in x is equal to 2, then that will give us minus a, so that's minus 2a. Minus 2a equals 2 minus 1, so that's 1. 1 times, no, actually, let's just write it out. P of 2 minus a, this is going to be equal to 1 times minus 1 times minus 3 times minus 5. We've just substituted 1 into everything like that, times q2. This is going to be equal to minus 15 q2. This is going to be equal to minus 2a because p of 2 is equal to minus a. And then same thing with p4, 6, and 8, right? That will give us p4 minus a. This is going to equal 3 times 1 times minus 1 times minus 3. This is times q of 4 times q4. This is going to be equal to 9q4. This is equal to minus 2a, right? And then next will be p of 6 minus a. This is going to be equal to 5 times 3 times 1 times minus 1 times q of 6. This is going to be equal to minus 15 q of 6. And this is going to also be equal to minus 2a by the same reasoning, because this is minus a. And lastly, we have p of 8 minus a. This is going to equal 7 times 5 times 3 times 1 times q8. This is going to be equal to 105 q of 8, which equals minus 2a. So looking at these values, we can see that the minimum a value, this is going to be the LCM of, it's the least common multiple of 15, 9, and 105, right? LCM of 15, 9, and 105. This is going to be equal to 3 times 3 times 5 times 7, which is going to be equal to 315, right? This is 315. So that's the answer. It's B. Number 22. Let ABCD be a cyclic quadrilateral. The side lengths of ABCD are distinct integers less than 15 such that BC times CD equals AB times DA. What is the largest possible value of BD? If we have a cyclic quadrilateral like this, and let's say this is A, B, C, and D, then now let's label the lengths. Let's say this is A, B, C, and D. They're in lowercase. And so we see that BC times CD equals AB times DA, so that gives us that AD equals BC. And here we can, we want something about BD, so let's draw BD like that. And we can use the cosine law on both of these triangles, right? So if you use the cosine law, then that will give us that, first for this triangle, we can see that BD squared is going to be equal to a squared plus d squared minus 2ad cosine of a, right? Cosine of a, this angle. But then, because of this triangle, that's also a triangle, so we are also going to have this is equal to b squared plus c squared minus 2bc cosine c. Now, since this is a cyclic quadrilateral, we see that a and c, they have to sum to 180. And so a equals 180 degrees minus c, because it's cyclic. And so this gives us that cosine of a is equal to minus cosine of c. Since AD equals BC, if we combine that, we see that minus 2AD cosine of A is going to be equal to 2BC cosine of C. So using this, we can see that this is just equal to minus 2AD cosine of A, and so we can just substitute that in there. That becomes plus 2BC cosine of C. And so now if we just add these two values, then we're going to get 2BD squared equals, these two cancel, so we're going to get a squared plus b squared plus c squared plus d squared. And so now we just need to get the largest value of a squared, b squared, c squared, and d squared. For that, individual values have to be very high. So if a is 14, then b or c is going to be 7, and that's because of AD equals BC. So b or c is going to be 7, and let's say that it was b that became 7. It doesn't really matter. B is 7. That means c has to be 2 times d. So the largest values will be c is 12 and d is 6, right? So c is 12 and d is 6. And so those are the biggest values. Let's just substitute them into there. So we would get that BD equals 2BD, BD squared equals all over 2, and then 14 squared plus 7 squared plus 12 squared plus 6 squared, which is 196 plus 49 plus 144 plus 36 all over 2. So this is going to be equal to 425 over 2, right? And so since we want the actual BD, then BD is going to be the square root of that. So it's root 425 over 2. So this is our answer. It's D. Number 23. Monic quadratic polynomials px and qx have the property that pqx has zeros at x equals minus 23, minus 21, minus 17, and minus 15, and qp of x has zeros at minus 59, minus 57, minus 51, and minus 49. What is the sum of the minimum values of px and qx? Let's say that px, this is equal to x minus a squared minus b, and let's say qx equals x minus c squared minus d, right? And so that means that the minimum values of px and qx, their sum will be minus b minus d. And so let's look at px first. This will have roots of a plus or minus root b. So this means that the roots of p qx, this will be when q of x equals this, right? Q of x equals a plus or minus root b. But then we see that Q of x is x minus d squared plus d, and so the Q of x, the sum of roots, will be 2c for any equation, right? So for both Qx equals a plus root b and Q of x equals a minus root b. So this gives us that the root sum is 2c and 2c. So 4c will be equal to all these summed, which is 4c equals minus 23, minus 21, minus 17, minus 15, right? So that gives us that 4c, this equals minus 76, right? So this means that c equals minus 19. So this gives us c equals negative 19. Now we can do the same thing for Q of x, right? Same thing, so its roots are c plus or minus roots d. The roots of QP of x will be when px equals the roots are going to be when p of x is equal to plus or minus, c plus or minus root d. So the p of x sum of roots are going to be 2a for both c and d, right? So that's going to be same thing as here. 4 of a is going to be equal to these four sum, right? That's going to be equal to minus 59, minus 57, minus 51, minus 49, which is equal to minus 216. And so that means a is going to be equal to negative 54. So we have a equals minus 54, and with these two things, we now see that px equals x plus 54 squared, minus b, and qx equals x plus 19 squared minus d. So using this value, since q is monic, it says monoquadratic polynomials, so this means that q of minus 23, this will equal negative 54 plus root b. And also we have this one too, so q of minus 21, this is going to be minus 54, and then minus root b. Here these are going to be q minus 23 is we put in minus 23 to here, so that will give us minus 4 squared minus d, that's 16 minus d. This equals minus 54 plus root b, and this one, if we put minus 21 into here, that will give us 4 minus d. This equals minus 54 minus root b, right? And so if we add them up, we get 20 minus 2d equals minus 108. So d would equal all over 2, 128 over 2, so that is going to equal to 64, right? So we have d equals 64. So now we can just substitute that into there, and so this is going to give us minus 60, negative 60 is going to be equal to minus 54 minus root b, right? So b is going to be 6 squared, which is 36. So we have b is 36 and d is 64, so this is going to give minus b minus d at last. So minus b plus d, this is going to be equal to minus 100. So this is the answer, it's A. Problem number 24. The set of real numbers x for which this is greater than or equal to 1 is the union of intervals in the form x is greater than a and less than or equal to b. What is the sum of the length of these intervals? Okay, so first, if you see this thing, we notice that this much, that's just a horizontal line like that. And so if we translate this by like some number horizontally, then that won't affect the intervals. And so let's say x is equal to x plus 2010, and let's just move them 2010 horizontally. So this is going to give us 1 over x plus 1 plus 1 over x plus 1 over x minus 1. This is going to be greater than or equal to 1. And so if we multiply by that, that's going to give us all over x plus 1, x minus 1, x squared minus x, plus x squared minus 1, plus x squared plus x. This is that minus that is going to be greater than or equal to 1. And so if we put out that 1, so if we put it back over there, then that's going to give us minus x plus 1, x minus 1, x, right? And so this is going to be equal to this much, that is equal to minus x cubed plus 3x squared plus x minus 1 all over x plus 1, x minus 1, right? This is greater than or equal to 0, so we see that this much should be greater than or equal to 0. right, minus x cubed plus 3x squared plus x minus 1 is greater than or equal to 0. And so here the intervals are minus 1 to a, and minus 1 to a, 0 to b, and 1 to c, right? Because these become a, b, c, where a, b, and c are the roots, and a, b, c are roots of this, right? Roots of minus x cubed, etc. The sum of the length of these intervals, that's going to be a plus 1 plus b plus c minus 1. This is a plus b plus c. This is the sum of the roots of this, right? And so if we get that, that's going to be 3. So this is the answer, it's C. Last problem, number 25. For every integer n is greater than or equal to 2, let POW of n be the largest power of the largest prime that divides n. For example, POW of 144 would be POW of 2/4 times 3 squared equals 3 to the second power. What is the largest integer m such that 2010 to the mth power divides this? Okay, so first of all, we have to prime factorize 2010. This is going to be equal to 2 times 3 times 5 times 67, and 67 is a prime number. And 67 is the largest prime number, and so we just need to look at the number of 67s in this, right? This is the product sign, the product of all n is 2 up to 5,300, like that. Now we need the number of multiples of 67 inside every number from 2 to 5,300. So a number of multiples of 67 between 2 and 5,300. That's going to be equal to 5,300 over 6 over 67 floor plus 5,300 over 67 cubed over 67 squared floor, and then that's it, because 67 to the third power, that's going to be much larger than 5,300. And if you do this, you're going to get 79 plus 1, which is 80, right? And so that means we have 80 multiples of 67 between 2 and 5,300. And for and now for 67 to be the largest prime factor, we need to take out the primes that are between 67 and 80, and these are going to be 71, 73, and 79, right? These are just 3 numbers. The 80 numbers, we're going to have 3 numbers that where their POW of n is not going to be a 67 power, right? And so 80 minus 3, this is going to be equal to 77, and that is our answer. It's D. So that was it for the AMC 12B from the year 2010, and thank you for watching.